Hey, top realized math industry, and we are going to be doing long division rationals, part 2. So, in the last video, we've been learning about long division and how we learned that in 5th grade. But we've also learned how to do long division, but with algebra. So what we're going to do is try to solve something a bit more complicated. Ooh, so there's a complicated problem right here. How are we going to apply long division so it would help us get to our answer? We will need this thing right over here. So how do we set it up? Well, going to the problem, we know that the bottom one is going to be x to the power of 3 plus 2x squared minus 3. So that's going to be right here. Minus 3. But what about the top one? The top one is not really ready to put into the problem. Notice how there is a 4, a 2, a 1, and a 0. When mathematicians try to do algebra, they love it when they have things in its standard form, the equations in its standard form, but also when it's simply going down the powers or down the line. So we are supposed to say 4, 3, 2, 1, 0, but we go from 4 to 2. So something's missing. So what we have to do is add a placeholder, because adding something else is going to mess up our work. And it's not going to go out evenly. So 2x to the power of 4 plus 0x to the power of 3 minus 5x squared plus 3x minus 2. If you were to do any math without the 0x to the power of 3, then it will be very impossible, because you can't have a x to the power of 3 subtract by like x to the power of 4 or negative 2. It won't work, and there'll become an error. Let's get started. So what we're going to do is, since we use the first exponent with the divisor as what we plan out to use to find out what the answer is, let's see what happens. So if I use x to the power of 3 and try to get to 2x to the power of 4, what can I use to get there? Well, if I use a 2x right here, if I do x to the power of 3 times 2x, it will bring me to 2x to the power of 4. Let me increase the line right there. So 2x is going to work for that. But now we have to do the entire problem. Now we have to color the entire thing in red, because that means when you find out what you're multiplying with, we have to find out by multiplying that and see what we get. So we have, of course, the 2x to the power of 4, but then we also have, when you apply 2x times that, plus 4x to the power of 3 plus 0x to the power of 2 minus 6x. So that is what's going to happen when you have this multiplied by that. So what we can do now is try to drain all this math to get it to 0, so it would work out. So every time we multiply, we must divide. Well, not divide. Every time we multiply, we must subtract. So we have to do some subtraction action. But every time you make a subtraction action, everything must be in the opposite, meaning that we have to put this in a negative, put this in a negative, put this in a negative, and put this into a positive. So now we subtract. 2x to the power of 4 minus 2x to the power of 4 is 0. 0 to the power of 3 minus 4x to the power of 3 is negative 4x to the power of 3. That is how we had to use that placeholder. Because if we ever did a square, then we couldn't really do anything because they're different exponents. Then we do minus 5x squared minus 0x squared minus 5x squared. And last but not least, if we do 3x plus 6x, we get 9x, but we have to add it. That 2 was not used, so we bring it down to negative 2. Now, we have to repeat the entire equation again. 2x is up there. But now we have to find another number right next to the 2x. We have an x to the power of 3 and a negative 4x to the power of 3. What can I do to get me there? What can be a fragment of this and that to get me to negative 4x3? Why don't I say just negative 4? Because that should be easy to understand. Negative 4 multiplied by x to the power of 3 is going to bring me to negative 4x to the power of 3. So that should work as negative 4x to the power of 3. Sounds simple. But when you multiply by the rest of it, you're going to get this multiplied by the red area, or the red part of the equation, negative 8x squared. Then we add by 0x, and then we add by 2. But remember, you see how we made a second equation? We now have to do the subtraction action. But every time you do a subtraction action, everything on the second part of the equation is going to be the opposite. So negative becomes positive, negative becomes positive, positive becomes negative, and positive becomes negative. So let's see what happens. This and that is going to bring me to 0, because this plus that is 0. If we do negative 5x squared plus 8x squared, you get 3x squared. We're going to add that, but the 0 is not necessary because it's drained down to 0. Then we have to add that to 9x plus 0x is just 9x. And negative 2 plus 2 is going to be plus 0. So that was drained down to a neutral number, which is 0. So we have 0 plus 3x squared plus 9x plus 0. But we only need to keep the 3x squared plus 9x. But why? Because the overall goal when using long division in any kind of level of math, like 5th grade math, middle school math, especially high school math, the end of the game, or the goal of the game, is to drain all that math to 0 right here and try to find what's up there. But there is one little problem. Yeah, we did find what's up there, but that stuff right over here was not drained to 0. What do? Turns out that when you get this kind of scenario, there's a remainder happening. It's just like when you say, if I say 14, divide that by 3, that would ultimately give me 9, but also a remainder of, actually, it would be a 4 remainder of 2. So that's because 14 is not a perfect divisor with the number 3. But we say that 3 times 4 equals 12, right? But then we have 2 left over. So that's why in this small case scenario, we have 4 remainder 2. But about this problem, since it was not drained down to 0, this answer right up here is also going to be a remainder. Also, the 2x minus 4 is some kind of answer we got, but we can say that it's not a perfect factor, and it's not even a good factor of this right here, but also that right there. So when you try to do the problem right over here, we can say that 2x minus 4 is going to be the answer that we got. But we do have to add in the remainder because that's also useful information that we have. So here's our final answer. 2x minus 4, then we have to add that by the thing that we divided with on the bottom, x to the power of 3 plus 2x squared minus 3. But on the top is going to be the remainder that we got. 3x squared minus 9. Or 3x squared plus 9x. Sorry about that. But wait. Since that there's a lot of math in this, there is a possible way that you might have gotten an error. And there was a little error. It was just a simple math error. See how we have a positive 2? If you do the negative 4 multiplied by the negative 3, you get a positive 12. And that is our math error. So it doesn't change the entire problem because we already done everything here. But we have negative 2 minus negative 12 because it's the opposite. So this is not supposed to be the answer. It was going to be 3x squared plus 9x minus 12. So you see how you need to double check your answer for this kind of problem because you could make mistakes. So right over here, we have to add not a minus 12, a minus 14. Another error that I just accidentally did. Because negative 2 minus negative 12 is negative 14. So over here, we put a negative 14 right over here. And this is our final answer. So when you do these kind of problems, it's a good idea to finish them before doing anything else because you might make a mistake by being distracted, and it's very hard to know where you left off. And also, there's a high chance of making a mistake, just like we did right there. I hope this video has helped you understand long division rationals. Thank you for watching Taoping Airlines Math Industry. Like and subscribe.